Hello, everybody, and welcome to today's edition of the Short Pharmaversity podcast. My name is Neus, and I'm gonna be your host today. I'm very glad to have with me Diana Löber in the line today. It's not the first time, and I'm very happy every time we repeat the session. For the ones who do not know Diana, Diana is Global Product Manager of Vials at Schott Pharma, and she will be sharing today with us her knowledge about the newly developed laboratory test that helps to assess the strength of different vial options. Hi, Diana. Nice to have you here.
Hi, News.
So, Diana, if we have you here, okay, we'll talk about vials. The keyword today is strength. Yeah. So, my first question would be: is the strength actually that important?
Yeah, good question, News. So, of course, topics related with the drug stability, so such as drug container interaction or container closure integrity, will always be the top priority for our customers because there it's really about the drug stability itself, and this is, of course, the most crucial. But with the maturity of the market, additional topics move into focus, and therefore also production efficiency. This plays a more and more important role. And when filling in bulk vials, you always have certain to a certain extent glass-to-glass contact, even on the newer filling lines. And in addition, you always have axial compression and side compression that is forced onto the vial. And this increases, of course, the risk of cosmetic defects that in the end might lead to breakage, especially when under these compressive forces. And of course, this is something you want to avoid on your filling line. And even more important, this is also something you do not want a nurse or a doctor or a patient to experience when using the drug, actually. And therefore, the number of customers asking for strengths-related data is continuously increasing at the moment.
Mm-hmm. I understand. We've talked several times in the Pharmaversity too about the ready-to-use or ready-to-fill vials, and okay, there's no glass-to-glass contact. So couldn't we say, yeah, then just take ready-to-use vials?
Yeah, you are totally right. Of course, this definitely is a solution, to avoid glass-to-glass contact and therefore decrease the risk of breakage. But this market, so the market for ready-to-use vials and the setup of these new machine technologies, etc., is still in an early stage. Yeah, I mean, we see that more and more customers are moving into this direction, also for mass production even. But it will take some time to convert this whole market. Yeah, and also my belief is that a part of the market will stick to bulk filling. Yeah, also on the long run. So this is really my opinion here. And of course, especially when you consider less developed markets, low value drugs, etc. So when you look at this topic globally, I'm sure that part of the market will stay in bulk also in the future.
Okay, I get it. So we have the filling lines and the filling facilities that we have. So the strength remains an important issue. So the topic of the session is okay, the newly developed a laboratory test to test the strength. So let's go to the test part. What is now new with this test?
So I must start with a little bit of background information here. So first, maybe a little bit of theory. Yeah, so the strength of a vial highly depends from its geometry, but also very much from the way the vial is treated. Yeah, so meaning what defects are introduced into the vial surface during transport, filling, handling, etc. And therefore, it is also important to mention that even a cosmetic defect with a very tiny appearance can have a major impact on a vial strength. But what is usually specified to the customer from us, so from Schott Pharma, but as well as from our competitors, are dimensional parameters and cosmetic defects. But as just said, this actually doesn't tell you anything about the strength.
Hmm. Like when Florian Maurer, our colleague, says the vial is like or glass is like an elephant, doesn't forget anything that has
Exactly.
happened. um, okay, so what you're telling me, would this mean actually that pharma customers or pharma companies are somehow blindfolded when it comes to strength?
Yeah, so actually this is the case, and this is also somehow surprising when you consider that we are dealing with an industry that is highly regulated, highly controlled. So what we've done with Everett Strong, yeah, one of our special vial options, and I think I'm sure that we have done it as the first provider, and I think that we are still the only one doing this, at least that I'm aware of. We have specified a strength threshold. So meaning we assure to the customer with a defined AQL a minimum strength for axial and as well as for side compression. And by the way, it's 2000 Newton for axial compression and 1000 Newton for side compression. And that we are able to achieve this is based on an improved geometry, but by staying within ISO. And we have a dedicated production process and what we call a flawless handling. So we make sure that we do not have any glass-to-glass contact.
Mm-hmm. Nice. But coming back to the test part, why exactly and what you actually need to test for? I'm you're making this really exciting.
sorry for the detail news. But I think it's important to understand the background here. So the thing is, even though we are providing with Everett Strong a strength specification to our customers, it's only valid for their incoming inspection. Meaning, what is happening after this is, of course, not under our control. And that is when the vial actually is experiencing these impacts. Yeah, glass-to-glass contact, side compression, for example, during annealing, axial compression, then being stoppered and being crimped. And in the end, the strength after fill and finish is the critical one, because that is what is being sent out to the end customer. Yeah. So I talked about nurse, doctor, etc. But of course, this is difficult for us to assess. Yeah, because we do not have a bulk fill and finish machine standing around here, what we can use to test different vial options with regards to strength. Yeah. So, I mean, luckily in the past, we were able to perform those kinds of tests at our customers and partners' lines. But of course, this is nothing what we can do on a daily basis and where we can rely on.
Sure. So you mentioned the average and what average vials experience along the process. So would this mean that the average strong, for example, is, yes, let's say useless because it loses the strength as long as it advances the line, or this strength feature get destroyed on the bulk lines?
Yeah, so fortunately, this is not totally the case. So the average strong vial still stays stronger than an average vial does, but it loses a significant percentage of its strength. And this is, of course, a pity when you think about it, because you have a really, really strong vial, really optimized with regards to its so how it can bear impact, etc. And so then it's a pity, of course, to see such a vial losing its strength. And by the way, we've seen this in real life tests, but as well as in our lab tests.
Mm-hmm. So would it be correct to say that the new laboratory test is all about simulating the effect of a bulk fill and finish line?
Exactly. So it's really about this simulation. So we wanted to create a reliable tool that we can use regularly for internal design verification to test how the vials perform after fill and finish. And therefore, it is crucial to be able to generate characteristic fill and finish line defects on vials in a reproducible manner.
Okay. And how do we know that defects are characteristic?
Yeah, so that's the reason why I work really closely with our colleague Florian Maurer on this test. And you mentioned him earlier because he is like really the guy, yeah, when it comes to strength and reliability testing and fractographic analysis. So he's really a genius when it comes to this. And by the way, for these people who do not know what is meant by fractographic analysis, so this is all about examine the damaged or destroyed vial and defining the root cause of the breakage. So based on the debris you get, you can actually state, or Florian can actually state, where the origin of breakage was coming from. Yeah, so this is what we call fractographic analysis, because I know that some customers are not familiar with this. Yeah? And yeah, so I don't know how many vials Florian has tested and analyzed in his career, but there have been a lot. Yeah, and I mean, really thanks to his, and of course his team's comprehensive knowledge of characteristic vial defects, but as well as based on our experience with these real-life tests at customers' fill and finish lines, yeah, we were able to set up this test method.
Could you mention some of these characteristic defects? What are those?
Yeah, definitely. I mean, so typical defects that are strength reducing and are introduced during bulk fill and finish are bump checks and scuffs. And these are contact damages, yeah, either due to the contact between the vials against each other, yeah, so glass to glass, or due to vials, bumping into parts of the filling line, so mostly metal contacts. And so let's go a bit more into detail. So I said bump checks and scuffs. So scuffs are also called chatter marks sometimes, and these are fine external surface abrasions, and they are introduced, yeah, especially like I said already, due to the contact to other vials or to other materials on the fill and finish line. And they typically show this interrupted pattern. So not a straight line, but a line which is somehow interrupted, yeah, or an area which is interrupted. Because they are, for example, introduced when the vials are rubbing against each other, especially when being in wet situations. Yeah, and the other typical defect is a bump check. And these are also sometimes called bruises. And that's a surface mark that is usually in a crescent shape, so meaning like a boomerang or a banana. Yeah, and they are typically caused by a high mechanical impact or a high glass-to-glass contact. So really when one vial is bumping into the other, let's say. Usually they are not penetrating the wall, but it might get to this at some point. But they are definitely affecting the strength. And they are also typically accompanied by the scuffs that I mentioned earlier. So these surface marks, let's say. But the tricky thing is, yeah, during visual inspection, you might consider a defect actually as harmless, yeah, as only being superficial, because you simply cannot evaluate the depth of it, yeah. But you might see the width and you might see the length, but not the deepness of it. So how deep it actually goes into the glass, how deeply it actually affects the glass. So from ordinary visual inspection, you cannot draw any conclusion with regards to the strength.
I remember this being told by Florian that this is like a two-dimension observation, but the relevant one is very often the third dimension, which is not visible. Exactly. Okay. So how do you make sure that the defects you mimic really mirror the strength loss, let's say in a real life?
Yeah. So there really the data of the real life fill and finish tests come into play. Yeah, because based on these, we understand what destructive effect filling lines can have on the vials. Of course, I mean, there are also variances between the different lines, but typically you see a loss in strength of around 30, 40, or even more percent. Yeah. So meaning a really strong vial at start can end up as a really weak one in the end. But this is, of course, not the only thing you need to consider. You also have to take into account the initial strengths. Yeah, so the starting strengths, let's say, of the vial. So meaning a really weak vial at start in the beginning typically is not able to lose as much as an initially strong vial. Yeah. So in the end, it's actually about two things: having a strong vial in the beginning and protecting its strength throughout its lifetime.
This sounds easy to say, protecting it. Um, if I understood you right, bulk filling is and will be in many cases unavoidable. Yeah. So this means impacts on the line are here to stay.
Yeah, yes, exactly. Indeed, it does. So it is like this. We cannot avoid the glass-to-glass contact and other impacts on the line. But the good news is we can protect the vial strength. And this is why we focused in this laboratory test and also in my presentation on the resilience of Eric strong and smooth vials, because there you actually get the best combined. So you have this geometrically optimized vial, yeah, with regards to strength, so the strong part. And in addition, you have an outer coating, yeah, so what we call the smooth part, the average smooth. And we have really seen the protective effect of this outer coating during the real life tests we have done. And of course, we wanted to reproduce and verify this in this newly developed tests as well. Yeah. And this is why our approach is take the vial with the optimized strength, Every Strong, and combine it with an outer coating that protect actually its strength, so Every Smooth.
Yeah, the optimal recipe combination of the world, exactly, of the world. Thanks a lot for taking the time, Diana, today and sharing with us the experiences and the results of the developments until reaching the right solution. You're part of a dream team, and I'm sure we'll have the pleasure to host you again in future and learn more about the Everick family and other innovations that you, together with the team, drive forwards. Thanks to the audience for hearing this podcast. Bye bye.
Bye bye, News.